Welcome to Supra Technical Series video number 2. In this video we're going to take a look at DTC diagnosis and the ABL. Okay, in the previous video we looked at a number of different things. The first thing we looked at was pad mode, or diagnostic mode, the mode that the vehicle needs to be in to where all the ECUs are communicating with ISTA. We also learned about the importance of connecting the DCA 8000 as a power supply. It is the only tool that we have that is able to produce the amount of amperage needed to sustain pad mode. Then we also learned about starting a case, calculating a test plan, and then closing that case once we were done with it. Now in this video, we're going to do two different things. We're going to learn about an ABL. And we're also going to do guided diagnostics on a DTC. Let's start with the ABL. What is it? ABL simply is a procedure. Remember, Supra uses guided diagnostics, and an ABL is going to be one of those procedures that will guide you through diagnosis. Now as we get started, if you have any questions concerning starting a case or getting to the point of starting the ABL, please refer to our first video in the Supra Technical ISTA series. Let's pick up where we left off on the last video, calculating a test plan and exploring a diagnostic ABL. Now if you remember, the 4 tabs across the top, you go across them as you calculate a test plan. Here we have some DTCs, and we're going to go ahead and hit calculate test plan, and now here we are in service plan. Now here's the ABLs related to those DTCs. We're going to choose the one for intake pressure sensor. It's gathering the information for diagnosis, and here we go, the test module based on the DTC, and then it's given us a conclusion or description as well as some details. This would be equivalent to freeze frame data. And then if there were any additional system information, it would be here in this tab. So let's get to the test module itself. I'm going to hit next. And here's the additional information that it's gathered for us, the wiring diagram. Remember, they refer to those as SSPs. Then the functional description. Here's the description of the air pressure sensor itself. Remember, they refer to these functional descriptions as FUBs or FUBs. It has also gathered the FUB or FUB for the B58 engine. Now, let's go ahead and get into this test module. It first wants us to do a functional check, then to check the wires and connectors, and then come to our conclusion with feedback. Okay, so we're going to go with the functional description to start out with. And we're going to check the intake manifold pressure sensor and hit next. Okay, so it's telling us right here that with the engine off, it's going to utilize the ambient pressure sensor, the intake pressure sensor, and the charge pressure sensor and compare the two of them together. Okay, and it takes about 30 seconds here to get everything going. Notice my vehicle is in pad mode and my DCA 8000 is connected. And a couple more seconds and we'll begin. Okay, so it has gathered the information from those sensors, and they should be even at this point with the engine off. So really we have a difference in pressure between ambient and boost pressure sensor signals that equals 1772 HPA. And if you read right here, it says with the engine idle, we should have no more than plus or minus 25 HPA. So we definitely have a discrepancy. Hitting next, it tells us that it can be the sensor, or it could be the wiring or plugs. And here we go. We are going to start our test right now. Start by starting the engine up, just as ISTA's told us to do. Okay, and we're going to hit next. Now, ISTA automatically is going to change the RPM of the engine to analyze the signals. And see if there's a difference while the engine is running. It's going to bring the RPM up. And in 3 seconds, bring us back to idle. Okay, now it's saying that based on what we're seeing with it idling now, we can see the difference here as well. So we're going to hit next. Okay, now it's going to put it in park mode and then put it back in pad mode in just about now. Okay, that's it for the functional check. Now it's back to the beginning. We're going to go back to the main menu now. So it definitely could be the sensor. We just need to rule out the wiring now. With the functional check done, let's go on to checking lines and plugs, or in other words, wires and connectors. Hit next, and it's saying that we're going to check between the components of the engine control unit as well as the sensor itself. And it says to make repairs as necessary. Remember, we've got our SSP or wiring diagram. We also have all of our different bits of information for this ABL. So if I full screen it, I'm going to zoom in. Okay, I'm probably going to zoom in a little bit more. And there it is. There's our intake pressure sensor right there. Okay, that is the actual name of the part right there, and when we click on it, it gives us a component location as well as the FUB, the functional description of it. And the component location is referred to as the EBO. Okay, I'm going to click back on the wiring diagram, go back to full screen. Okay, now this is referring to the connector of the air pressure sensor. Shows the same component location, but here we have the STA, or the connector view. Here it's giving us the tool we need to diagnose for pin fit and opens, shorts, whatever the case may be. Okay, go back to my wiring diagram, hit full screen. Now notice this dotted line connected to the engine ECU itself. Right there, that dotted line showed everything that was in that connector A462B. Gives me the EBO for it, and then here is my connector view. Right there is the tool that we need to use with our breakout box to test it at the computer side. Click back on wiring diagram, go full screen, and let's go all the way over to the end. Remember that connector was A462B. Here's A46, or the engine ECU in and of itself. When I click on that in the SSP, gives me a component location, also gives me the FUB for the engine ECU, then also gives me a pin assignment. This is very similar to our terminals of the ECU section of the repair manual. Click back on wiring diagram, go full screen, and back over to our air pressure sensor. Now, looks like we have 4 different wires. And first of all, coming from the DME or the engine ECU, I've got this one. If I click on it, it gives me a description. This happens to be the 5-volt reference going to it. Go down below it. Now here is the signal wire for the pressure sensor, the yellow one. Then here I have the power for the intake air temperature sensor that's part of this assembly. and then here's my ground. Now notice the numbering on each one of the wires. This is how it's going to correspond in both connectors, A46-2B as well as the one for the air pressure sensor. Okay, so when we use our breakout box, this is what we're going to use number-wise. So based on the EBO, I'm going to expose the connector for the DME or engine ECU. There they are, the different connectors for them. From there, I'm going to take the vehicle out of pad mode and disconnect the first connector so I can get to the second one, A46-2B. Now, if you remember, when we clicked on the connector view in the SSP, we saw special tool numbers. Here's the one for the DME or engine ECU. So this is the number right here that we saw on the SSP. Note the tools being used right now are part of our rental program and will be discussed in later videos. Okay, so let's hook it up to the DME or engine ECU. It's meant to be a piggyback type connection that's going to connect to the actual engine ECU wiring and then hook straight up to the DME or engine ECU. This will be a way that we can actually see power and ground coming from the ECU. Plug back in the connector number 1 and we should be good to go. This side is going to go into our pinout box or breakout box. Here's an example of the breakout box as you would receive it from the loaner program. And here's an example what the breakout box looks like. Okay, with the breakout box out of the container, notice that there's an A right here for the in that goes from the control unit. There's a correlating connector that plugs into the side of the box itself. Once it's secure, then we move on to the other end. Okay, so let's connect our breakout box to our piggyback harness that's connected to the DME. Once it's nice and secure, I'm going to go ahead and put in the set screws and we're ready. Last thing to do is to go ahead and connect the supplied ground for the breakout box. Screw that down on the set screw, and then I'm just going to take ground right to that post where we have the DCA 8000 connected. Now with my multimeter, I'm going to take the black lead and alligator clip it right to that ground. Turn my multimeter on and use my red lead to go ahead and plug into the breakout box. So remember, at this point we are checking what's coming out of the DME or engine ECU at this point. So we're going to look at our 5 volt reference, which is terminal number 28. Okay, so on A, the ECU side, we're going to use the red slots or terminals to check. And we're looking at number 28. So I'm just going to plug my multimeter in. We have 5 volts coming out of that ECU. Checking the ground will be easy now. That's terminal 38 as you see here on the diagram. So going ahead and taking my black lead out of the standard ground now, I'm just going to plug it into terminal 38. I read 5 volts, therefore my ground coming out of the ECU is good. Last of all, let's check our signal wire. That's terminal 33. Now, I'm going to go ahead and just take my red lead and just plug it into 33. I should read 5 volts because I have an open circuit voltage at that signal wire. I read 4.9. Just right. Now I'm going to use my black lead of my multimeter and move it back to the common ground in preparation for testing the sensor side to rule out the wiring. Remember, there was a special tool for the B439 connector as well. This again is a special order tool. Right here is an example of the tool kit. It has both male and female terminals of all different sizes. Here's an example of the male terminals. Here's an example of the female terminals. Also included with this wiring kit is some long banana clip leads to connect your multimeter, along with other terminal fitment, as well as ways to splice into wires. This is a gauge set right here that helps measure male terminal sizes so you can get the correct wiring. Let's check the sensor side now. The way we're going to do this is by looking at terminal number 2 of that B439 connector. Okay, with my ground already on the breakout box, I'm going to use these red long banana clip leads that come with the kit. And using a size number 2 terminal, this is how we will check it. Now mind you, BMW does not back probe. They front probe with a proper size terminal. And that's what we're going to do here. So using the SSP, I'm going to find out which one is number 2 and plug it right in. I should have 5 volts. Sure enough, I do not have an open in my wiring going to the sensor. Now, let's go ahead and check our ground wire. I'm just going to take the ground off the breakout box now and use another male terminal wire to check it. Plugging this into the ground, I should still read 5 volts. And I do. I know my ground wire is good. Okay, so removing our ground from our multimeter from the breakout box itself, we connected it to another male terminal and checked it on that terminal number 3. And we had 5 volts. That's how we know that our ground is good. Last one to check is our signal wire. I'm going to do that by simply taking the red lead out of terminal 2 of B439 and put it right into terminal 4. So if my signal wire is good, as I take it from terminal 2 and put it into terminal 4, it should read that 4.9 volts like we saw before. Sure enough, my signal wire is good. My only conclusion I can make is that my sensor is defective. The next part of this diagnostic ABL is to end the test module with feedback. So click on there, hit next, and I have the choice of the intake manifold pressure sensor being defective, lines or plugs being defective, and then no fault found. Of course, it's going to be the sensor. And that's the end. Hit next, and now it brings us back to the ABL. The only thing left to do is close out the case. The first part of closing the case out is deleting all of the fault memory. So clicking on fault memory, I went ahead and started the process, and now it's going to completely clear out all faults that were saved before. It's going to deactivate pad mode, put it back into pad mode, now remember that we have the 4 different tabs across the top. It was under vehicle management that we went ahead and found the screen for clearing out fault memory. And once we did so, now we're in the vehicle information tab as it goes through the process. Once it's all done, the only thing left now is to close out the case.